All right, good morning, everybody, to our continued discussion on different bases, number systems, and so on. We are pretty much at the end where what have we done? Let's have a look. Let's think about what we've done. For each number system, our questions have been the same. Let's have a look. Our questions and things that we have practiced are convert from our familiar decimal system, convert to the decimal system from whatever number system we have looked at, and then we looked at the written method for addition, subtraction, and of course multiplication. These are the only 5 things we have done over and over and over for different number systems. Number systems. And as we are at the end, I like to have a big picture of what did we do? What is expected of me? Do I have any gaps? Do I know everything that I'm expected to know, and so on? We started with the Roman numbers. We continued to the Babylonian system. Then we had different versions of the one-hand system, which I'll say it over here, we can call a base 5 system. That's really what we've done so far. So when we look at an example of where we left off uh, last time, we, for example, have base 5 number like maybe 2, 3, 3 base 5, and that then converts to 2 groups of 25 plus 3 groups of 5 plus 3 ones left over. This 5, of course, here, this 25, of course, is because we are working in a group size of 5, and each place is an increasing power of 5. So what do we have here? We have 50, then we have 65, 68. So we have our number system representation, whatever the system might be, base 5, for example, with modern symbols, and we can convert it to a decimal number. And we can, of course, go the other way as well. So the thing that you might be thinking is, why did I choose a 5? It seems so arbitrary when through history we've settled on 10 as being the ideal um, base, counting in groups of 10, which is why we're doing it in our decimal system. I just chose the 5 because it came from the one-hand system, and it's a smaller one where Babylonian was bigger and was a little bit more clumsy to work with 60. Choosing a smaller one makes the little bits of arithmetic easy, yet it is different and I have to think carefully. But it is arbitrary in a way. So what we could do is we could have any Sorry, that was a y. We could have any number as the base. It doesn't have to be 5. It doesn't have to be 10 like our decimal system. It could be anything. Now, of course, it can be 60, and then you're in some form of the Babylonian system. We don't need to go that big, but we can alter it to really see, do we understand this uh, base number system by changing the base, not a 5, not a 10, but something else. So that is the last little bit, using other bases to again do the same things we've done before. So let's say here, general base system. Doesn't have to be 5. 10 would be our decimal system, but it can be anything. And then the questions are the same. Convert to and from, do the arithmetic, and we will be done with part 2. Now, if you look at the schedule, I have scheduled 2 days for this. We won't, I think, need the whole 2 full days, but I don't think one is really enough in case there are questions and things we need to elaborate on. And I don't want to rush it, so we have 2 days, but tomorrow might not be full. So if you want to fill tomorrow as well, make sure you bring some questions. And of course, as we go, as always, feel free to interrupt me with any uncertainty you may have. So let's have a look at some exercises. In 7.7, there are some that I can practice with to just see what's different, what do I have to pay attention to, what's similar, and you'll see if you've been keeping up with what we've done, a whole bunch of stuff will be similar. It's not a new question, it's not a new method, nothing's new here. We are just changing the base for additional practice. Now, in applications, there are some benefits to having different bases. Base 16 has some applications, base 2 has some applications, uh, but we're just mixing it up just for the sake of it. So we have 3, 3, 1, 5, and we are working base 8. So I need that subscript to tell me what is the size of the group that I'm working with. You have to tell me. And if nothing is written, then it's a decimal number. If it's anything else, there needs to be a subscript. So I'm not reading this. I am not reading this as 3,315 because that is not what is happening here. I need to figure out what is the decimal number. So I'll put little arrows here because it's our first other base number. So this is our ones. These are our groups of 8, number of 8s. That will then be number of 8 squared and the number of 8 cubed. Because my group size is 8, each place is counting in powers of 8. So this then means right to left, left to right, it doesn't matter. 3 groups of 8 cubed plus 3 groups of 8 squared plus 1 group of 8 plus 5 leftover, or 5 ones. Now, these might be a little bigger, so it's perfectly fine to get a calculator and see if you get the same answer as I do. So let's see here. 3 times 8 to the power of 3, which I may or may not know. 3 times 8 squared, I know that's 64, plus 1 times 8 is just 8, plus 5 times 1 is just 5. What do we get? We get 1,741. Put a comma there if you like it. This guy is decimal. Whoopsie. This guy is a decimal number. See, there's no subscript. That is my answer. Put a box around it, use color, do whatever you want to do. So, thinking about a test, you definitely don't want to write just the answer. The answer is important, but you need to show how you get to that answer. Do you understand what base 8 means and how I get to my decimal number? And then if you happen to make a little calculator mistake or whatever, I can see, oh, no, no, you understand that you're working with powers of 8. It was just a little mistake, and I can still give you some marks. All right. So not much has changed. We're just mixing up the base to focus on the method involved. Because if I understand the method, then the specific detail of the number system, assuming it's a place value system, is quite irrelevant. The underlying method is much more important. So here I have next 3213 base 4. Notice how I say it. Then let's not write it underneath and see. I definitely want to write something, and more would make the quiz answer better. But let's just see if we can understand the places here. Right to left is still how I think about it. Ones, fours, 4 squared, 4 cubed. So it'll be 3 times 4 cubed plus 2 times 4 squared plus 1 times 4 plus the last 3 times 1. Use your calculator, don't use your calculator, doesn't matter to me. But let's see something in the chat. 3 times 4 to the power of 3, which you don't have to remember. 2 times 4 squared is 16, plus 1 times 4 is 4, plus 1 times 3 is 3. And we get 231. There I can say 231 because that's a decimal number. All right. So hopefully that isn't strange at all. It's just the base value that is changing. The group size is changing. Then the last one. Again, I don't want to go too fast, so let me know. 17550, and that is base 9. Let's have some arrows again, maybe. Number of ones, number of nines, number of 9 squared, number of 9 cubed, number of 9 to the power of 4. So this one's a little bit bigger. 1 times 9 to the 4 plus 7 times 9 cubed plus 5 times 9 squared plus 5 times 9. I'm going to fit it in. And then it's just a formality. Let the calculator tell you what it is. 9 to the power of 4. I don't care to remember what that is. Plus 7 times 9 to the power of 3. Maybe you remember it, maybe you don't. Plus 5 times 9 squared, I know is 81. Plus 5 times 9, I could have just written 45. And 0 times anything is 1. And we get 12,114. That is my decimal equivalent value for the quantity being represented. Okay, so check that is this one actually. Convert to a decimal number from whatever place value system you are in. Okay, so now we are done with that question for the whole part 2. No more number systems. Let's convert the other direction. And here is where I feel it's more important to be consistent and to plan. How am I going to lay out my answer? How am I going to present my answer? Because you're not there to make to elaborate and make adjustments and explain your answer, you need to really present it in a clear way. It's very important. And converting from decimal to a different base value system could be considered the more complicated of the two questions. So I want to present it in a clear way. This is my suggestion, but feel free to alter it if you like. So the given number is 5094. I want to know base 3. Base 3. I'm actually going to go backwards. I'm going to do base 7 first. I'm going to do base 7 first. So I want to know what is my powers of 7. Powers of 7 that can fit in here. That's going to be used. So the largest power of 7, well, maybe I don't know my powers of 7, right? I know 7 squared is 49, and maybe that's it. 7 to the power of 3. 7 cubed is 343. That's still quite small. So let's see what the next power is. 7 to the power of 4. 2401. That can still fit. But obviously, if I have another times 7, then I'm going to go into the 16,000s, and that's too big. So my highest power of 7 is going to be 7 to the 4, which is 2401. I didn't know that. Once I've selected the highest power that can fit, I cannot skip any other power going down. And 7 cubed we found was 343. 7 squared is of course 49. 7 to the 1 is 7. 7 to the 0 is the ones column, or the ones place rather. Then I want to know how many times can it fit. So let's say here number of times to fit, or however you want to give this a heading. So 2401 can fit in there twice. How do I know? I divide it. My given number divided by 2401. Let me show it. It's our first example. There could be someone that needs to see all the detail, and that's why we're here. 5094 divided by 2401, and I get 2 and a little bit. I don't care about the little bit. I want to know how many whole times can this power of 7 fit. So 2. Then I want to know how much have I used. Well, if I times it by 2, I get 4802, of course. So sometimes it's going to be an easy arithmetic to do. Sometimes maybe you need a calculator, or all the time, whatever. Just make sure that you have the right numbers here, because what comes later relies on that. So I've used a lot of the quantity rather, but I still have some left over. Now I don't want to feel like I'm guessing here. Maybe I want to use the calculator and make sure. Maybe I want to try it in my head first and then double check with the calculator, whatever works for you to get the answer safely. So 5094, take away 4802. MathBot says, nope. Oh, there it is, okay. 292. Okay, so that's what's left. And now I see my next group size is 343. Can't fit in. I can fit none of them in. I've used nothing. I still have left my 292. That's okay. I just needed to check because the place value system needs to take note of how many of each of these group sizes um, are used. So I can't skip anything. Then 49 is my next group size, and I can certainly fit a few of those in. It's gonna be, well, this is close to 50, and 50 times 5 is gonna be 250. So I'm thinking 5, but I am maybe not 100% confident. Let's double check. 292 divided by my group size, and I see it is 5 and almost 6, but not 6 whole times, only 5. Then I have used 5 times 49, which I may want to do in my head. I may want to double check. My mouse is completely stuck. Oh, there it goes. I can double check. 5 times 49. 5 times 49. And it is the 245 that I may have thought that it is. Or maybe you weren't sure. Maybe you didn't care. Either way, we want to be sure to get that number. Then we still have a little bit left. It's good with these small ones for me to try and practice some mental arithmetic. Otherwise, it's never going to get any better. It's just going to get worse. So 92 minus 45, well, 92 minus 40 is 52, minus another 5 is 47, but maybe you want to check that on the calculator. It's totally fine. And I see another group of 49 couldn't have fit. So that's my check. I can see the group size versus what's left. I can't fit more in. So then I'm ready to move on to the next smaller group size, which is 7. 7 can fit into 47 6 times because 6 times 7 is 42. So it gets easier once the numbers get a little smaller. And I have 5 left. Those will be mopped up by the 1s. I used them all, nothing left. And I've broken up my number, my decimal number, according to powers of 7. So let's write that underneath here. 5094 is 2 groups of 7 to the 4, 0 groups of 7 cubed, 5 groups of 7 squared, 6 groups of 7. You can write 7 to the 1 here if you want to. And 5 groups of 1s, or 7 to the 0. Therefore, the base 7 number is 20565 base 7. So it's really this column over here that tells me the place values, but I need to systematically have a way to systematically break up the decimal number. So this direction for the conversion, decimal to another base, is the more time consuming one, where I want to be careful with my little calculations, because if I make a mistake, for example, up here with the 292 and I miscalculate it, everything else now relies on that, and everything else could then be wrong, unfortunately. So I want to have a layout, a presentation, a strategy that helps me minimize my mistakes. Mistakes can still happen, but if I show my work like this, then hopefully I've lowered my chances of making a mistake. All right. It seems like we have space for the next one, which I'll go backwards and use B. Actually, I'm not going to use B. B is silly because we've done base 5 already. Scrap that. I'm not doing that. We've done base 5. We want to practice different bases, so I'll jump to A. Base 3. So again, I've now established how I want to set it up, how I want to present my answer. I'm going to do that. So I want to see the number here, 5094, right? Yes. So I want to look at powers of 3 in this case. How many times can it fit? Number of times to fit. How much have I used? How much is left? And those columns seem to do the trick for me. I don't need more, but I'm not comfortable doing fewer columns. This is what I personally like. Now, I don't know all my powers of 3. That's not a requirement, but I need to find the highest one that can fit into 5040. So a little guess and check is perfectly fine here. Let's try 3 to the 7. So 3 to the power of 7. I'm totally guessing. Oh, wow, that's a very good guess. Maybe secretly I wasn't guessing. 3 to the power of 7 is 2187. 3 to the power of 7, 2187. Now, 3 to the power of 8 will be this times 3, which is obviously going to put me in the 6000s, which is too much. So I know this is the highest power of 7. But maybe you didn't get it the first time. Just trial and error, go as high as you can go. Once I found it, I need to go all the way down, not skipping a single power of 3. I know the smaller the base, the bigger this table is going to be because the jumps are smaller. So maybe I know, maybe I don't know. I don't know 3 to the power of 6. Let's see. 3 to the power of 6. Whoopsie. 729. 3 to the power of 5. Maybe I don't know. Let's find out and be sure. 3 to the power of 5. 243. Now, sometimes, the more you do these, you start to remember the small ones. 3 to the power of 4 is 81. 3 cubed is 27. 3 squared is obviously 9. And then 3, and then 1. But definitely make sure we need these values. Correct, right? All right. Now I start at the top with my quantity in decimal 5094. How many times can 2187 fit? Obviously, twice. How much have I used? Maybe you want to try the mental arithmetic. Maybe you don't care at all. That's up to you. It's up to you. 2 times 2187. And we've used 4,374. Then I have a little bit left. The arithmetic is actually very nice in this case, 720. But you don't have to be confident in that. Let's show it. 5,094. Whoa, I did something very bad here. Hold on. Oh, no, hold on. I have some Discord technical issues. How did I do that? Hmm. Hmm. Discord is acting really weird. So strange. Okay, let's see if I'm back on track here. 5,094 minus 4374. Okay, seems to be okay. And it's the 720 that I thought. Sometimes I type in the chat and it zooms in and out. I don't know why. Who knows? Anyway, so I have 720 left. My next group size is 729. Obviously, that cannot fit. It's close, but it cannot. I've used none of it. I still have 720 left. That's okay. I just need to keep track of it. Then for the next group size, 243, let's see how many times can that fit. I'm thinking 2 times, but let's double check. Double check, be sure. So 720 divided by 243, and we see it was almost 3, but it was not. It was 2. And then times 2 is not so bad. I've used really only times 2. Wow. 486. And another one would get me, you're right, it gets me so close, but not quite. Okay, so I've used of the 720, 486. So I have a little bit left. Again, maybe you want to practice, maybe you don't. Up to you. Subtraction. 720 minus 486. And we get 234. Did I do that right? Sure. Some 81s can fit into that. Only 2 of them. 2 times 81 is 162. And you see here that I have 72 left, which wasn't enough for another 81. So whatever I have left can't be the same or bigger as the group size I'm working with, because then I could have fit another one in. Then I have 27 left. How many 27s can fit into 72? Well, 2 of them using 54. So the smaller these numbers get, the easier my arithmetic is going to get, and I have more confidence. Then I have used 18. Sorry, no, I've used 54. I have 18 left. And 18, right? Yeah. And my next group size is 9. 2 9s can fit and use all the 18 with nothing left. So then, of course, there's nothing left to fit 3s in. I've used nothing. I still have nothing. No 1s can fit into nothing. I'm already done. But I do need to say how many groups for everything from my starting point down. So my number was 5094. 5094. It is 2 times 3 to the power of 7 plus 0 times 3 to the power of 6 plus 2 times 3 to the power of 5 plus 2 times 3 to the power of 4 plus 2 times 3 to the power of 3 plus 2 times 3 to the power of 2 plus 0 times 3 to the power of 1 plus 0 times 3 to the power of 0. You think, well, oh, it's tedious to write this down. Why do I need to do that? I just want to find the answer. Sure. But if your answer is wrong, I need to go and verify that you know exactly how this works. And if you don't show enough work, show enough detail, now I sit there thinking, I don't know if they really know what's going on here. So I can't give you part marks. I want to, but give me a reason to. So 202222200 base 3. Wasn't that fun? The smaller the base, the smaller the groups, and the jumps are smaller, and there are more of them. So my representation tends to be longer. But still, there it is. No problem. Once I have settled on how I want to present it, I then just go through the motions and make sure of every calculation that I'm doing. Alrighty, alrighty. So, check off another one that we've now completely done for all the number systems we need. Then, the last things to do, just like always, are the arithmetic questions. But of course, there's a ton of similarity between these and the base 5 stuff we've done. I just now need to be extremely aware of what base value I'm working in. So we see here 7.8 has some addition and subtraction and so on. So let's just chip away at these. And if we run out of time, we will finish the rest of them tomorrow, with the remaining time, of course, being a Q&A session. But one day was not quite enough, I think. Yeah, it's not quite enough to do all the arithmetic at a pace that we're comfortable with, allowing for questions. So we will continue it tomorrow. So I have some addition, 6826 base 9 plus 5173 base 9. And that subscript needs to be everywhere if you are working in a different base other than decimal. Method doesn't change. I line everything up, give myself some nice space to work. Why not? I'm adding 5173. Nothing is going to change in the method. I just have to now be very aware that I'm counting in groups of 9. Groups of 9. That is really the only thing I need to pay close attention to. 6 plus 3 is 9. There is no 9 symbol here. Just like there was no 5 symbol in base 5. Now I'm counting in 9s. So 6 plus 3 in my language, I have a word for it. I have no symbol for it. 9 is one group of 9 and 0 left over. Next column, 1 plus 2 plus 7 is 10. 10 is one group of 9, 1 left over. Next column, 1 plus 8 plus 1 is 10 again. One group of 9, 1 left over. Last column, 1 plus 6 plus 5 is 12. That's one group of 9 and 3 left over. Another column is created here, but there's not much to do. So the answer is 13110 base 9. Understanding is always going to win. Understand what we're doing and see the similarities with what we've done in the past. We're not reinventing the method of addition. We are simply mastering that method. Next one is 412 base 6 plus 3344 base 6. Same method, line it up, give yourself some space, make it easy. 3344 base 6. and I'm ready to go. First column, 2 plus 4, I have a word for it. It's 6. There's no symbol for that. It's one group of 6 and nothing left over. It's very similar to the previous one. Oh well, random coincidence. Next column, oh wow, 1 plus 1 plus 4 is 6. That's one group of 6, nothing left over. Next column, 1 plus 4 plus 3 is 8. That's one group of 6 and 2 left over. Last column, 1 plus 3 is 4. So my answer is 4200 base 6. Again, once I get the hang of this, there's really nothing strange. I just have to be aware of my group size. It's now 6s. And if I forget that, it's very easy to fall into the trap because these numbers look so decimal because they're using the modern symbols, which I'm conditioned to see as decimal numbers. So I have to be very aware that it is not. Squeeze that last one in. 112 base 3 plus 1220 base 3. Set it up. 112 for the first number plus 1220 for the next number, and I'm ready to go. First column, 2 plus 0, 2. Write my subscript before I forget. Next column, 1 plus 2 is one group of 3 and nothing left over. Next column, 1 plus 1 plus 2 is 4. That's one group of 3 and 1 left over. Last column, 1 plus 1 is 2. Done. 2102 base 3. Of course, I am going fairly fast because this should not be new. If I am very aware of the group size, nothing else is new. And I should be already very comfortable with all of it. But please feel free to interrupt at any stage if I do something that you're not sure about. But once I see the similarities between this and what I've done, it should be quite straightforward. We have 6 minutes. Why not squeeze in some subtraction? Makes our job tomorrow even easier. So exercise 7.9 is the subtraction question set. I have 6004 by 7 minus 2204 by 7. We are never going to have different bases in a single arithmetic question because the only way to really handle that is to convert. And the point here, just like always for all the arithmetic, is to not convert to decimal or anything else, but to stay within the number system. So for example, if I have this subtraction question, I will never write a symbol that is not allowed in this number system. And the only symbols allowed in this number system are my symbols for 0 to 6. There is no 7, 8, 9. It's not decimal. So I don't love this really. I don't love using these symbols. They're too modern. They're too familiar. I like things like the Devanagari symbols to help me remember that this is not my decimal system. But uh, to make it easy to write down, we pick the modern versions of those symbols. It shouldn't matter. Just adds to the challenge. Can I look past what this looks like? So I'm subtracting. 4 minus 4 is 0. 0 minus 0, 0. Oh, so easy. 0 minus 2, oh, can't do it. I'm going to have to go borrow. I borrow 1. That then becomes 5. Now I can't go and write just anything here. Yes, I borrow a group of 7. I definitely don't want to do that. That is, it's not wrong, but it's very bad form, and it doesn't help. If I'm teaching someone else, that is incredibly confusing, and I will never do that. If I do it for myself, fine. But I'm thinking about teaching, so I'll never do it. Rather, I would just make 7 marks. It doesn't matter. Just 7 things to look at, to see. Because I can't write 7. 7 does not have a symbol. So I now see here I have in my language, luckily I have a word for 7. 7 things, take away 2 is 5 things. Then in the last column, I have 3 things. And I'm done. 3, 5, 0, 0, base 7. Let's squeeze in one more. Why not? B. 1, 2, 3, 1, 2, 3, 3, base 4, minus 3, 0, 1, base 4. So I really like the arithmetic because it doesn't require that I know what this quantity is. I don't care what the quantity is. What is 301 base 4? I have no idea. And I don't care. It's amazing. First column, 3 minus 1, 2. Oops. I thought I was going to write 7. No, it's base 4. Next column, 3 minus 0. So easy. Next column, 2 minus 3. Okay, can't do it. I need to borrow this guy, leaving nothing. And I'm borrowing. One of them splits into 4 things in that column. Now I have 6 things. Take away 3, 3. I'm not writing the 0 in front, right? That doesn't look good. So my answer is 3, 3, 2, base 4. We are going to, I encourage you to do 7.9 number C. Try it on your own before tomorrow. And then we will do that one tomorrow. It's good to try something on your own instead of sitting back, watching me do it, maybe have a nap at the same time. No, that does not help me for the test. You need to take out some writing instrument and start being active. All right. So like I said, we'll wrap up subtraction tomorrow and do the multiplication, but that is it. We won't use the whole session. Bring questions if you have them. Otherwise, I cannot fill the time. It is up to you. But one session wasn't quite big enough for all of this other basis discussion. All right. Are there any questions, comments on this?
Seems pretty good. It's just like the other base 5. So
Yeah, at the risk of boring you, it is quite similar. But if you can change the base comfortably, then you know there is nothing I can ask you in the quiz. There is literally nothing that can be a challenge or a surprise if you've uh, kept up with what we're doing. All right, so we will continue and wrap this up tomorrow. And then if you have any questions about the quiz, though this one's pretty straightforward, uh, be sure to ask that tomorrow, and then we'll finish it. Until then.